Hi everyone, welcome to Math Moment with Mr. Dustin. I am Mr. Dustin. So today we're going to be discussing functions, and so I'm basically going to define what a function is and different representations of it, as well as some applications and different things to look for. So this video is geared towards middle school students. However, it could be a good review for high school students, especially in preparation for the SAT. So let's get right into it. What is a function? A function is a relation from a set of inputs to a set of possible outputs, where each input is related to exactly one output. So what does this really mean? Well, think of it as a machine of sorts. I want to put something in and get something out of it. So like we'll call this our, like machine. And then say I want to put something in. So I'm going to put the number 1 into this machine, and it's going to spit out 2. And that's kind of the idea of a function. You put something in, and then you get something back out. Only these somethings are numbers, typically speaking. So let's look at some representations of a function. Well, you can have a table, and this is a table here. You can see there's a row that has inputs, and then a row that has outputs. And so, we have inputs -2, -1, 0, 1, 2, and outputs 0, 1, 2, 3, 4. So that means the -2, the output is 0. And with input -1, the output is 1. And that's kind of how to read the table here. We also have a graph, which is over on the right here. Now, we see they've given us a function that is f of x equals -2x plus 2. And what that does is for every x, which is an input, we get f of x, which is an output. So if you put 1 in, you're going to get 0. And that point is shown here. If you were to put 0 in for x, you'll get 2. And that is accomplished by, solving this section here, multiplying the -2 times whatever you put for the input, and then adding 2. So these are basically the typical representations we have of functions. We'll use tables, we'll use graphs, and we'll use equations. So with that, let's go into a break, and we'll get into some important features as well as applications after the break. All right, so for the break today, I decided to show you a project that I made in high school involving many functions. So for some context, this is a drawing of my favorite Star Wars character, Yoda, who is down on the left here in mostly green. And then he's fighting who is supposed to be Palpatine, Darth Sidious, what have you. And this is like a Star Wars reenactment, and he's shooting lightning from his hands like he does in the movies. So I just used all these functions here and limited how far left and right they could go. That is called the domain. And that's not something that we need to get fully into right now. And so we can see that I used some numbers here. Oh, and here are some points, the -0.5, 0.5. Those are his eyes. And yeah, you can see all these really complicated functions that I'm not going to get into. But the point of me showing this was to show you that you can make really cool things with functions, like this drawing here. And functions can take many different, shapes. And all of these are functions. They only have one output for every input. It just so happens the way they look, it looks like there are a lot of outputs for each input. So I hope you enjoyed looking at one of my high school projects, and we'll get back into functions now. Hi everyone, welcome back. I hope you enjoyed the break. Let's get into some important features of the functions that we're discussing. So we have what is called the x-intercept, and so that is the point where the graph intersects with the x-axis. Now, what is the x-axis? Well, you can see in this graph here, we have a horizontal line with all these like numbers labeled on it. That is the x-axis. And then the y-axis is the one that goes vertically. but it's like the same idea. They serve as labeling features, and it's kind of like a starting point for going up and down as well as left and right. So the point where the graph intersects the x-axis is the x-intercept. So on this graph here, you can see it's where I'm circling thereabouts because it's the red line is crossing the x-axis. Now the y-intercept is the same thing, just about the y-axis, the point where the graph intersects with the y-axis. So that's going to be right here at 0, 1. Now we read these graphs basically naming a coordinate that goes left and right, and then naming a coordinate that goes up and down. So, for example, take this point 0, 1. We consider 0 to be right here in the center, and then 1 signifies we go up 1. So what this is telling us is we went 0 left and right, and then we went 1 up. Now, if we take a look at 1, 3, we went right 1 to get here, and then up 3, 1, 2, 3, to get up to this point. So in all of these coordinate pairs that we're given, these ordered pairs, we are told which way to go, left or right, based on the number being positive or negative. Notice how positive numbers are to the right here, and the negative numbers are to the left. And we're told left or right first. And then we're told up or down. Same thing, positive is up, negative is down. And so that's just kind of how to navigate the graph in a very quick explanation there. And as you do more of these, this will become more of like a conditioned thing in your brain. Another thing we look for is slope, and that is the rate at which a graph increases or decreases. So it's essentially like the steepness of your graph here. So I'm not going to get into how to find the slope in this video, but that's just the general idea of slope there. Now, let's look at some application problems. So we have 2 problems that are SAT practice. And so if you're in middle school, you may or may not want to stick around for this part. And so let's get into these problems here. Number 19, a food truck sells salads for $6.50 each and drinks for $2 each. The food truck's revenue from selling a total of 209 salads and drinks in one day was $836.50. How many salads were sold that day? Wow, that is a lot of information, and it takes a minute to kind of process what we're looking for. So we want to make 2 functions, essentially. And what we're going to do is we're going to find where they intersect. Now, we want a function that tells us the price of, the salads and the drinks. So we know there's $6.50 for drinks, and then $2. Whoops, I read that wrong. Sorry, salads are $6.50, and then drinks are $2 each. Then we also know that they sold 209 salads and drinks. And then the money they made was the $836.50. Now, a good way to go about this is to pair all of the monetary facts here that they give you together. So what I'm going to do is I'm going to do $6.50 times, let's call it S. That is the number of salads, plus $2 times D, which is going to be the number of drinks. And this makes sense, right? Because you would multiply the price by the number of salads you would sell and the number of drinks you would sell. We also know that in this scenario, that ended up being equal to $836.50. So that is one equation, one function that we're, well, this is technically an equation because there's no changing output here. So now we're going to write another equation. This time we're going to figure out how many salads and drinks were sold. So we're going to take the number of salads plus the number of drinks And notice we already have an answer for this. That's 209. That's what they give us. So now from here, now that we have the setup, we will solve them. Now, I've already done a video last summer on solving systems of linear equations. So I'm not going to go into the work for this. Instead, I'm going to show you a graph. So you'll notice the red graph is the first equation here. And then the blue graph is the second one. And all I want to do is find the intersection point between them. Now, this is important because we put salads first. That's what I used for X. This program likes X and Y, so that's why I used that. And then the drinks were the Y. So when we see this coordinate, we know that X is equal to 93. And that is because it corresponds with the X-axis. That's how far right we moved. So 93 is going to be how many salads we sold. And that was the question. So we know that the answer is B. Now, let's look at the second problem here. Number 3 is what it's labeled. On Saturday afternoon, Armand sent M text messages each hour for 5 hours, and Tyrone sent P text messages each hour for 4 hours. Which of the following represents the total number of messages sent by Armand and Tyrone on Saturday afternoon? So we want basically an M plus P situation. And that's going to be equal to something. We'll call that Y. So we need to multiply each of these by the number of hours that these guys spent texting. So we have 5 hours and 4 hours. Well, Armand did 5 hours, and notice he is M. So we're going to put a 5 here, meaning 5 hours times the number of text messages each hour. Then Tyrone is P, and he did 4 hours, so it's the same reasoning here. Now, which of these options is exactly like what we just wrote? And it would be C here. So these are just a couple of applications for functions, and that's basically all you really need to know about functions at this stage. And your teachers in high school and middle school will go over them more in depth. So to summarize, a function is a relation from a set of inputs to a set of possible outputs where each input is related to exactly one output. I cannot stress that enough. Each input has one output. Otherwise, it would not be a function. And then functions are represented by graphs, tables, and equations. Some important features include the x-intercepts, the y-intercepts, and the slope. And then functions help us to reason with rates of change and practical scenarios that involve them. And that's more referring to what we just did with these applications here. So that is all I have for this video today. Thank you so much for watching. There is a quiz that you can take. The link is in the description, and I encourage you to take that just to see how well I did in conveying the concepts here. So thank you for participating and watching this video, and we'll see you again next time.